Hello, and welcome to Inspire Tokyo. I'm Chris Galucci. The Inspire Tokyo podcast is brought to you by Kikoku Shijo Academy in Tokyo, Japan. On this show, we interview leading figures in science, the arts, education, business, and politics to help young bilingual students learn more about potential career paths for their future. Today on the show, my guest is Elizabeth Tasker. She is an associate professor at the Japan Aerospace Exploration Agency, otherwise known as JAXA. Her research uses computer models to explore the formation of planets and galaxies. She earned her PhD in computational astrophysics at the University of Oxford in the United Kingdom. Before joining JAXA in 2016, she taught physics for 4 years at the University of Hokkaido in northern Japan. In September of 2017, her popular science book was published, titled The Planet Factory: Exoplanets and the Search for a Second Earth. Engineering and Technology magazine calls it engaging and informative, a great introduction to a relatively new and fast-changing aspect of scientific endeavor. Having read her book myself, I highly recommend it to anyone who wants to learn more about exoplanets, and even for anyone who is remotely interested in the topic of space. If you're like me and have a fascination with space, but have let it lay dormant for a while, this is a perfect book to help rekindle your interest. And with that, here is my interview with Elizabeth Tasker. Hello, Elizabeth. Thanks for joining us today.
Well, thank you very much for having me.
So let's go ahead and jump right into it. The first question I'd like to ask you is, you've done numerous interviews and answered hundreds of questions, and I'm sure you get asked the same questions over and over. So what is the most common question that you get asked that you wish people would stop asking you?
When will we find intelligent life? To be fair, I completely understand why people ask this question, and I would also love to know. But the problem is, we only discovered the first planets outside our solar system about 20 years ago. So for a science field, this is really young. And the field is moving really breathtakingly fast. But we still don't know what these planets are really like on their surfaces. What we see is them as shadows as they block the starlight and move in front of the star, or we see them in a slight wobble in the star's position as their gravity tugs on the star during their orbit. Now, this tells us a planet's there, and it also tells us how big it is, either its radius or its mass, but it doesn't tell us anything at all about whether it could be habitable. Now, we're now on the brink of changing that, because our next generation of telescopes are going to be aiming at detecting the planet's atmosphere. So having a good sniff at the types of molecules in the air will give us our first indication of what sort of activities are going on the planet's surface. But until we start knowing this for a whole lot of worlds, it's going to be impossible to even guess how many of them might be able to support the most primitive type of bacterial sludge, let alone a bunch of aliens with a Starbucks and iPhones. So while finding intelligent life would be amazing, where we are now is absolutely incredible. We're on this brink of finding out whether planets like the Earth are really common or whether they're really rare, whether life could be elsewhere, and therefore, are we rare? Are we alone? So let's not jump to the end point and demand to know where are the aliens with iPhones, because this journey is going to be outstanding.
Very good points there. I opened with that question so that in case that question was on my list, I could take it off. But we're safe. I didn't have that on there. So I think most of us, when we were younger and we were introduced to the idea of space and planets and our solar system, we were absolutely fascinated by it. And but then I think at some point it stops there, and we stop asking questions. For you, when did your love for space begin, and then why did you decide to pursue it as a career?
Well, I just thought it was really cool, and I just never really stopped thinking that. So I think really my question to you is, why did you stop thinking that? Because is it not really cool? But it is true that for years as a child, I really wanted to be a vet. I mean, I'd read all the James Herriot books about life as a country vet in the UK, and I was completely sure that my destiny would see me rocketing around farms in the English countryside on some kind of 4x4 Land Rover to rescue calves from upside cows' bottoms. I mean, this was my destiny. But in the meantime, my dad took me to the planetarium when I was about 8 or 9, and I remember buying this beautiful poster of Saturn that sat on my wall for well into my teens, I think probably until I went to university. And it was just incredible to me that these huge, massive planets were there, orbiting our sun, just like we were. And like all the time, like even when I went to school, when I had breakfast, they were just there, hanging out. It just continued to blow my mind. Now, at school, I studied, obviously, physics, chemistry, and biology, and was still very determined, yes, vet. And then I actually got a careers test. And they said, Elizabeth, you're not really interested in anything to do with being a vet. You're actually completely obsessed with physics and astronomy. Have you actually thought about studying physics at high school and then on to university? And I was like, oh, yes, okay, good point. So I did.
Mm-hmm. Excellent. Yeah, I actually like the question you posed me about why did I stop learning? And I had that thought to myself when I was reading your book. I'm like, wow, this stuff is truly fascinating. Why have I not picked it up before? And it might be that I just haven't found a good popular science book that kind of like sparked that interest in me again. So tell me a little bit about this book, specifically the moment that you decided that you wanted to write it, that this book should exist.
Well, I've always wanted to write a book. I mean, hasn't everyone? Wouldn't it be great just to see your name on a shelf? I mean, seriously, who doesn't want to do this? But it is, I have to say, quite a lot of work. So I'd always enjoyed writing, and for many years I kept a personal blog, which was a great compromise because they were short posts, I could knock them out in a few hours, I got instant feedback, and if I made people laugh, I loved that. It was great. And my personal blog just include random anecdotes from day-to-day life. So there is the time I couldn't find the flush bottom on a complicated Japanese toilet. There's actually several posts in that series. There's also the time I went to what I thought was a science conference and there was a strange alien trapped inside a bottle in the foyer. And all kinds of stories like that. And a few years ago, I decided to take these blogs from where they were sitting on blogger.com and I put them all together on my personal website, along with details about me and also articles that I was starting to write from the media as a scientist. So I was contributing articles to, popular news sites, telling them about science discoveries I just found interesting. And when I did this, I obviously added a contact page because everybody adds a contact page to their personal website. And I jokingly put messages, screams of adoration, and offers to turn my blog into the sensation that makes me the second female novelist to make the Forbes billionaire list. Please fill in the boxes below. And for the record, the first female novelist on the Forbes billionaire list is J.K. Rowling, who was published by Bloomsbury, who also became my publisher. Oh. And indeed, one morning I woke up and, I groggily checked my email on my phone, as I do, and I heard is very bad for you. And it was actually an email from Bloomsbury, amusingly titled Forbes Billionaire List Possibilities. And they said that they were starting a new imprint on popular science, and would I be interested in contributing a book? Now, you heard the term opportunity knocks. I thought it was very unlikely this would ever happen again.
Right.
So if I was going to write that book, it was going to be now.
Now would be the time.
So I wrote the first chapter and presented a book plan and went through the official, commission procedure. And the rest is history.
Excellent. Well, I'm glad they contacted you. So in reading your book, I was doing a few Google searches on various things. My history looks very different in the past few weeks than it has before that. And I come across a lot of websites of fans of space, not experts of space. And so it was really kind of hard for me to kind of wade through what was true and what wasn't. From your point of view, as the expert, what are some of the biggest misunderstandings you hear people talk about when they talk about space?
So that is a pretty easy one for me because there's one that is driving me absolutely bonkers. It's, we have discovered an Earth-like planet. Guys, you haven't. You've discovered an Earth-sized planet. But may I point out, Venus is Earth-sized, and it is not Earth-like. Mm-hmm. The surface temperature of Venus is about 460 Celsius. It melts lead, and the longest a spacecraft has ever survived on the Venetian surface, less than 2 hours. So Earth-sized does not mean Earth-like. And as I mentioned before, at the moment, we don't know what the planet's surfaces are like. We know their size. We know how much radiation they receive from their star. But there's so much that goes into making an Earth, For instance, the type of rock on our planet helps control what gases are in our atmosphere and keeps our temperature cozy for life. Our oceans are needed for all life on the planet, and our magnetic field wraps around our world like some kind of Star Trek cloaking device and stops violent flares from the sun sterilizing our surface. And there's even more that's to do not just with the Earth, but our position in the solar system. So we think our planet may have formed completely dry without any kind of water, and the water may have been delivered by icy meteorites knocked towards us by Jupiter. So if we had a planet that was actually very similar to the Earth, but there wasn't a Jupiter in the system, would it even have water? We just don't know yet. And even if it did, it could be the opposite effect. Planets could be too wet. There's a system that was recently discovered called TRAPPIST-1, which has 7 Earth-sized planets. Very exciting. But actually, many models of their formation suggest that oceans might be so deep that actually life couldn't get the nutrients it needs, and they may be completely sterile. So we found lots of Earth-sized planets, but we're only now at the point of trying to find out if they're Earth-like.
Alrighty. This next question I'm not really sure how to ask, so hear me out. In a lot of scientific disciplines, anthropologists, for example, they can physically touch the early remains of humans and do their science that way. Paleontologists work with pottery, etc., other things that they dig up. It's kind of hard to touch a planet other than Earth, and you can't really feel the orbit of a planet or a star. So can you speak a little bit about what it's like to do science where you can't really touch the things that you're studying?
So it is one of the hardest things about astronomy and astrophysics. I would love to get a planet, put it on a bench and just cut it open and find out what's going on inside. It would be amazing. But we can only observe, and once more, we can only get one look at an object from one angle, our position on Earth, at one time, right now. Since the time it takes for a planet to form, for instance, or evolve is much longer than the lifetime of a human. Our solar system is 4.56 billion years old. So it's really a long time for anything to change. So what we tend to do is we use a lot of computer models. And with a computer simulation, you can try different starting points and fast forward and rewind time, and then see how these compare with the observations that we do have to build up a picture of how a planet may have formed and what might happen to it later. And this helps us make very educated guesses to what these worlds might be like. So, for example, in that TRAPPIST-1 system I hinted at earlier, computer models suggest these planets may have formed far from the star and then moved inwards. And this is why we think they may have these very deep oceans, because they would have been born where it is much colder and therefore packed a lot of ice into their body. And as they move to warmer climates, this may have melted to produce incredibly deep seas. Now, of course, we do have some planets we can go and poke. We have the others in our solar system. And combining these fields, planetary science, which normally is concerned with solar system planets that we can literally go and give a poke to or bring back a rock from, with exoplanet science is really something we need to do at this stage. As you mentioned, the Earth is a planet. We are standing on it. And how it works and functions is incredibly relevant to us understanding planets that we can only observe at a distance.
Got it. You mentioned computer models, and in your field, are there standard computer models that people use or standard programs to create those models? Are there worldwide databases that all astrophysicists have access to? Maybe can you just speak a little bit about the technology in your field?
So in terms of observations, finding a planet is pretty difficult. So therefore we need, there's only a few telescopes in the world that do it, and they tend to be very big international collaborations. So for getting the data, everybody knows what the options are. Once you process the data and you want to compare it with models, you're more on your own. There are codes that are commonly used among multiple different groups, but you can also write your own if you're interested in looking at one particular aspect. And then people share them through research publications. So the way all science is shared is through conference talks, but then also publications in the big journals, and that's how we find out what each other are doing and what we're up to. And we often share data sets through that way as well. So you might say, I've done this analysis and I found this, and the simulation data is available here. Go and check it out yourself.
Fascinating. So I have to ask this question. If you could travel anywhere in space to see something with your own eyes, where would you go and why? And of course, there are certain places that you can't go because you would be killed instantaneously. If that didn't happen, where would you go?
I would really like to check out a few super Earths. So these are the most common class of planet that we've found so far. But the size sits between Earth, our largest rocky planet in our solar system, and Neptune, our smallest gaseous one with these huge atmospheres. So what are these? Are they giant supersized Earths? Or are they teeny tiny little gas planets? And if they're rocky, what are their surfaces like? Does the fact they are mega-sized mean they have a very strong gravity that flattens all the mountains and you have this completely pancake-like landscape? And does that mean that if you're very flat, if you have any water, does it just cover all the land? I really want to know.
That is quite fascinating. In fact, I think it was in one of the recent Star Wars movies. Was it Star Wars? There was a world entirely filled with ocean. Maybe it was another.
I think it was Star Wars. I think the clones might come from an ocean world.
Yeah. Fascinating stuff that could actually be
absolutely
true. So you just finished up your book. You're doing the book tours now. You might have a little bit more free time on your hands. Are there any other projects that you've had to put on hold that you're working on now that you can dedicate more time to?
So, yeah, I mean, my job's pretty keen on me doing the job as well, for some reason. So I managed to get off a bit of time and use up my leave travelling around touring the book, and now I'm back. They're like, yeah, remember we're employing you? I'm like, oh, right, yes. So one of the projects I'm currently working on is trying to explore exoplanet data that we have using things like machine learning and neural networks. And this is very popular buzzwords you hear all the time. Oh, we're doing neural network work because everyone is. But the idea here is that you build a computer program that learns patterns in the same way that a human does. So, for example, you can identify a bus on the street, and that's because you've seen lots of examples of what a bus is. So you might not think about what makes it a bus, but you might have subconsciously found patterns that says, oh, well, if it carries people, if it follows a fixed route, and if you're paying to ride, chances are that is a bus. And if you grew up in London, you'd probably say it has to be red. So a neural network can do the same. It can take a large collection of examples and try and find links between them. And one of the advantages of this is it's a very independent look at the planet catalogue we found. So a computer doesn't know what a planet is. It has no preconceived idea of how it might have formed or what it should look like. So instead, it just literally takes the data and says, what are the links we're seeing? And it also has no problems finding what we call higher dimensional links. So when we try and find trends between planet properties, for instance, radius and mass, or radius and distance from the star, we plot them on 2D graphs. It's very easy for the human brain to see it like that. We can more or less do that in 3D, but when we're trying to find links between more patterns, more parameters than that, it's just, we can't visualize it. But a computer really doesn't care. It's perfectly happy to find a trend if it exists between, say, radius, length of the orbit, and the star mass, and mass. And it will link all those together and tell you if there's some kind of grouping that's going on there. And by finding that out, that might tell us something about how planets form, that we're getting these trends that are appearing in the data.
Alrighty. So there's a ton of information in all of your answers, which is amazing. And I'm sure there are some young listeners out there wondering how you can go from knowing nothing to knowing all of this. Do you have any advice for anyone out there who is thinking about a career in science and what they could do, where they could begin, things of that nature?
So I would say the most valuable lesson I've learned, and to be honest, it's one I'm still learning, and that is believe in yourself. I think many people feel that when they don't understand something, it's because of them. It's because they're not good enough. Other people understand it, they don't. They must be the stupid one. Actually, all it means is if you don't understand something, you have not yet found an explanation that works for you. And that doesn't mean you're not as good as the person sitting next to you that has understood the current explanation. Everyone's brain works differently, and that is why humans are so good at science. So if you don't understand something, do not give up. Just keep looking for different explanations and you will find one that works for you. And I think that can be true for girls and boys. I think it affects the genders a little differently in different disciplines. So, for example, girls, there's a lot of this feeling that, oh, girls don't like science, they're not good at science. That's just garbage. But I think because we tend to have these stereotypes, even if we joke about them a bit, it's very easy to think, oh, maybe I just can't understand this. No, it's because you haven't found the right explanation. And I think boys have exactly the same for other disciplines. If you are a very talented chef or dancer, you might get told, oh, boys aren't very good at this. Well, that's also garbage. Just find the right explanation, the right way of doing it that works for you, and you will be fantastic.
That is excellent advice, both for science and non-science fields. Well, Elizabeth, I think that's all of our time today. Thank you very much for joining us.
Oh, thank you very much. I've enjoyed it thoroughly.
All right. Take care. All right. And there you have it. Thank you, everyone, for listening to the very first episode of the Inspire Tokyo podcast. I'd love to hear from you, so please send your comments, thoughts, questions, or just say hi at hello@inspiretokyo.com. If you enjoyed what you heard today, please share it with a friend. We are always looking for new listeners. And be sure to subscribe to us wherever you listen to your podcasts. See you next time.